Hi, everyone. Please welcome Elle Meredith.
Hi. Can you hear me? I hope so. Okay. A lot of the things that I'm going to talk about in this talk from a book that's called Rails Anti-Patterns, so you should go ahead and read that. It's a bit out of date, so some of the code examples that it has is out of date, but most of the principles are pretty good. Also, I wanted to apologize to my students because I'm going to give the exact same presentation on Monday. So.
We don't need to do it now.
No, you don't. You can skip class. Okay, so what are anti-patterns? So anti-patterns you can define as a common approach to recurrent problems that ultimately prove to be ineffective. So it's a repeated pattern of action, process, of structure that initially appears to be beneficial to your code base, but ultimately produces more bad consequences than beneficial results. And then what you do with that is you find a refactored solution that is clearly documented, proven in actual practice, and repeatable, which is how we define anti-patterns. So what is refactoring? Improving the quality of code without changing its behavior. So pretty much changing the code, improving the code, but not adding new features along the way. To be able to do that, we need to have tests in place. We can't really refactor without testing. So let's start with the first example. Knowing too much about your neighbor's neighbor. So in this case, we have a very usual or common structure. We have an address that belongs to a customer. We have a customer that has one address and has many invoices, and then we have an invoice that belongs to a customer. In a view, we might want to find the customer's address. So we might do something like invoice.customer.name and invoice.customer.address.street and invoice.customer.address.city and so on and so forth. So does anybody know what this code smell code like?
Train wreck?
Besides a train wreck.
Oh.
Low emitter. Yeah, that's true. Low emitter. I don't know how to say that properly. Sorry. So the solution for this smell, and the problem in this one that we are pretty much reaching out and across two other classes to find the information that we want. So a solution for that is to either use delegates or a presenter with a simple delegator. So let's look at the first example. In the first example, we have a customer that has an address and an invoice, and you'll see that we are delegating all the address attributes but delegate street, city, state, and zip code to address. And then since we delegated that to customer, so now we can just say customer.street. We can go into invoice and delegate all the things to customer and add the prefix true, which allows us in our view to use invoice.customer_name. Which means in our test, if we wanted to stop that, it's so easy to do rather than reach out and create all the objects along the way. We can use the second pattern to make it nicer is to use a presenter. So in this case, I'm using a simple delegator. I'm initializing that with an invoice and also passing the invoice to super, which means we can just reach all the other methods that are on customer. Then I'm defining whatever logic or methods or attributes that I want on the presenter. So in this case, I'm again defining a customer name, which reaches out to customer to call its name, and customer for its street. And in our view, we will need to initialize our invoice presenter rather than our invoice to be able to reach all those attributes. Fat models. So in this case, I have an example of an order class, and I'm just showing a few examples of some methods that it has, and it probably has a few more methods on it. And really, we don't care so much at the implementations of the various methods. It's not important for the purpose of the example here. But Rails, usually Rails encourages code to be down to the model view controller stack. So it takes it down to the model layer. Many anti-patterns can happen at the model layer, which one of them is that the models that we have do too much. For example, here. One way to solve this problem is pretty much think about trying to think about the single responsibility principle and breaking down a class into smaller classes that do exactly just one thing and do that well. So in this case, the other problem that I find in Rails is that a lot of times Rails pushes us towards to think that all the models and all the classes that we have should be active record based, and they do not need to be. So in our case, we can, instead of having all those methods on order, we pulled it out into an auto converter, which is pretty much what they're all trying to do. And we initialize the auto converter with an order and then define all the methods there to do all the different formats. And then in order, we delegate all those methods to converter, and in converter, we initialize the auto converter new and send self the order into the new class. So in this way, we're giving the conversion methods their own home inside of a separate and easily testable class. It's a lot easier to test this class now, and we are keeping in line with the single responsibility principle. Spaghetti SQL, and now this is not so much a bad example because it could be a lot worse, but imagine when you have a controller and you're doing a lot of SQL queries inside your controller. So Active Record is an incredibly powerful framework, and many new Rails developers fail to use it to their advantage. And note, for example, it's not taking advantage of the incredible utility of Active Record associations, which this is a perfect example. So instead of doing all those queries inside our controllers, instead, we can define scopes on our model. And in this case, Toy has it used to be called name scope, but a scope that's called cute, where cute is true. And then Pat should already have an association has many toys. And then back in our Pet's controller, we can use pet, we find pet, and then we can just do pet.toys.cute. Again, not a great example, but just an example of what we can do with just using scopes in models. Convoluted views, things that are undesirable that we have problems with. So views that include domain logics instead of just presentation logics when you're trying to figure out if you should display something or not. Even when we just have presentation logic, it can be overly complex as to overly complicate the view. So it's hard to know what's happening and change that later on. So it makes it harder to maintain or change the view later. And it makes it difficult to test whatever we are trying to test. Also, business logic in the views means that we have to repeat it in all the different view formats that we have, which again, are not very dry. So, solutions for that could be using custom view helpers, which we're going to look at in a minute, using presenters and decorators, which we looked at in the example before, and learning about template inheritance, which it's a good thing to go and research, which I'm not going to talk about now. So for example, we can use a custom view helper method that shows us that if there is a project, then gives us this URL, and if you don't have this project, then gives us a different URL. And our specs are really simple. In one case, we just build a project, and then really we don't even need to build a project. We can pass in a stub and create that, and otherwise we check for the different link that we are getting back. FAT controllers. A FAT controller typically includes business logic that properly belongs in the model. In addition, by removing the code to the model, we can unit test the code. Writing unit tests is often easier than writing functional controller tests. And it's not really the right place to do that in controller specs anyway. It's more appropriate to have the business logic in our models. Solutions for that is to move the business modules out to either models, we talked about that, to presenters, we had an example of that, or to service objects. But I want to talk about the different problems with FAT controllers is when People add extra parameters to URLs to make whatever they're trying to do work, or non-standard controller actions. So Rails 2, long time ago, embraced RESTful structure. And then in this context, RESTful structure simply means mapping to standard controller actions, which we have the 7 standard that we have: index, new, create, edit, update, show, and destroy, which match to the HTTP verbs post, put, get, and delete. And they match them rather strictly, adhering to all the ideas that in REST. And again, it's not a complete REST implementations, but it's close enough. So the 2 telltale signs of an application that doesn't use RESTful practices is 1, extra parameters in URLs used to identify what additional actions are performed by the controller actions. And the other one is non-standard controller actions. For example, when you have a user and you add a method that says confirm on it, or you have a method on a post controller that says publish, which is not one of our default standard 7 actions. So the 7 Rails actions have been fairly standard in Rails for some time, and there's still applications that don't use them and don't worry about mapping them to HTTP verbs. So, for example, if we look at this example of a controller, there are many problems with this code sample. Can anybody tell me a few of them?
Then on the ifs. Then on the ifs.
Then on the ifs is a syntax, yeah, which is not needed. If not, use instead of use unless, yes. Also, if not, and that checks for nil. Love that. Double negatives.
User find all, which is a deprecated syntax.
User find all is a deprecated syntax. No interpolation of string interpolation. Using a method that's called users instead of index. Anything else? Also, besides showing users, considering that looking at the params tells you something else that you're going to do, which is resetting their password. Just a few things that are wrong with this method. So if we are looking, so the solution for a problem like that is embrace REST and refactor non-RESTful actions into a separate controller. So in this case, do you have any ideas of what would you do different? Yeah.
Move it to a reset password action. Or a controller with a create.
Much better. So a much better way of doing it is actually separating into a different controller. Now, we don't have to match controllers to models that we have or tables that we have in the database. It doesn't have to be. So in this case, and I have a typo, it should be users controller, and we have a method that's called index, and we just grab in user.all, which again, be careful when doing that, but this is a different discussion. And then we have a password resets controller, which uses a create one because we are creating a password reset, and we are initializing a password reset service object that does all the things that we want. And I didn't include all the things that it needs to do. This is just an example. My other pet of Rails anti-patterns is callbacks. And looking at the guides for the Rails callbacks, it says callbacks are hooks into the lifecycle of active record object that allows you to trigger logic before or after an alteration of the object state. So actions can be performed before, after, or even around active record events such as save, validate, or create, or destroy any of the other ones. I just grabbed all the ones that are available from the guides, which are many. Developers usually notice callbacks pain during testing because they need to stub out the callback actions. If they don't, they need to add the supporting data structure classes or the logic in order for the test to pass. My favorite when you use callbacks is sending emails. You create a user and then you send user email in the same model is an example of, and you hear like horror stories when people deploy to staging and, or deploy to staging and then repopulate the database and suddenly heaps of emails being sent to users. Big problems. One of the problems with callbacks. A way we can do that, for example, here we have an order class. It belongs to a user. It has many line items. And then we have the after create purchase completion notifications, which pretty much calls on a mailer to deliver an email to the user. In a spec, we will need to mock that out or stub that out. So in this case, we would say, allow any instance of order to receive purchase completion notifications and return true, because we don't want it to actually touch a notifier in this case. A solution is to use an observer pattern, or, and in this case, we took all the sending emails out of order. So we still have that belongs to user and has many line items and all the other associations that we have. But instead, we will have an order completion class, and you see that it doesn't inherit from application record. We initialize that with the order params. And then we have a method that's called create, and then we say if order.save, then actually call on purchase completion notification, which sends out the email. Do I have an example? And then I don't have an example of the controller. And then pretty much in the controller, we will call order completion .new, pass it the order params, and call on create instead. Sluggish services. A big concern in interacting with remote services is how they might affect application performance. If a network connection is slow or has issues, or even if the remote service itself is slow or is currently having issues, the performance of an application may be severely affected. Solutions that we can use for that is move the tasks to a background job, or to set timeout when we are dealing with remote services. And I grabbed just a few examples from just using net HTTP, the standard Ruby library. And in that case, we have a URI. We are creating a request. Then we are initializing that HTTP with the host and the port, and we call on start. We set the read timer to 3. So it will fail, it will stop after 3 seconds, and then we actually ask to get the response back. And then there's a couple of other examples for Faraday and http.rb that just a tiny bit different syntax, but pretty much very similar. Next anti-pattern that I want to talk about is failure to respond. So if save fails, the error details that are returned, in this case, the error details that are returned to the client as XML. The client would need to check for the presence of the errors element and the response to see if the save was successful or not. Parsing the response to determine failure is less than ideal because it is more work for the client, and it's potentially more error prone than if the client could essentially just check a flag to see if the response was successful or not. So in this case, one of the things that we can do instead is to return explicit HTTP status code. So in this case, we say if song is saved, then we have a status of created, and if otherwise, we have status of unprocessable entity. And Rails has a list of status code and their corresponding symbols on their guides that you can check out whichever you have, or you can just return a number, a status number. Basically, with all those anti-patterns, the things to remember that if you want to refactor them, okay, so always be testing, and then always be refactoring. And this is me. Thank you very much.